And this is the last in the solution video series, and it's called Solution Stoichiometry. This seems to never go away. Stoichiometry, the heart and soul of so much of chemistry, predicting amounts. Now, solution stoichiometry is super easy. Let me give you the big hint. The hint. And that is work in moles. Moles are your key, and here's a shortcut, super cool equation. If you take the molarity and you times it by the volume, when you put them right next to it, that means times, that equals the moles. Now, how do I know that? Well, remember, molarity is moles per liter, and if I times it by liters, which is liters over 1, the liters cancel and you get moles. This, my friends, is the key to doing solution stoichiometry problems. So let's run through an example. 50 milliliters of 0.25 molar solution of aluminum chloride reacts with excess silver nitrate. How many grams of precipitate are formed? Like all stoichiometry problems, you start with a balanced equation. So forget the numbers, equations rule. So AlCl3 reacts with silver nitrate. Silver. So silver is Ag, charge is +1, nitrate is NO3 -1, so that's just simply AgNO3. This is a double replacement or a double displacement reaction, and they're going to trade partners. Now aluminum, if you recall, his charge is +3, and nitrate is -1, so this will be AlNO3 plus Ag is +1, chloride is -1, is AgCl. Now the balanced equation is not done yet because I got 3 chlorides and 1 chloride over here. So I'm going to put a 1 here, and that makes this a 3. That gives me 3 Ags, but that doesn't work here, so I'm going to put a 3 here. Now, that's the balanced equation. Now, if you don't know how to do that, we're going to work on that. Now, let's now write down what I know. I know that I have 50 milliliters of this, and it's a 0.25 molar solution. That's what I know. And it says how many grams of precipitate are formed. Now precipitate, as you recall, is a solid substance. So it's either this one or this one. Now you may have to refer to your solubility table, or there may be ways that you know how to do this, but this is the precipitate because this is the solid, this is AQ. All nitrates are always soluble, and the silver, all chlorides are soluble with some exceptions, silver being one of them. So when I say how many grams, I'm trying to convert to this. So I want to convert these two numbers now, into grams of this. Now it's just like one extra step stoichiometrically that you've probably said, oh, it's not that hard. So watch what I do. I'm going to start here. I'm going to say 0.25 moles of AlCl3 in 1 liter of AlCl3. It's actually a solution. That's fine. Notice I did not write capital M. I could have. I'll show you a different method to do this. And then I can multiply, remember, MV equals moles. I need to get rid of the liters. I've got the moles. I just want moles. I want to get rid of the liters. So I have 50 milliliters. Now, what I like to do, I start figuring this out in my head, and maybe you could do this. There's 1,000 milliliters in a liter, so I divide by 1,000. So I move it over 3 places. So that's 0.0500 liters over 1. All right, if you need to do the math on how to do that, that's fine. The liters, and that's AlCl3, the liters cancel. Now I have moles of AlCl3. And if I've got moles of AlCl3, I convert right here AlCl3 to silver chloride using the balanced equation. Now I've got AlCl3 on top here, moles, so I'm going to say there is 1 mole of AlCl3. Now that number came from right here to 3 moles of silver chloride. Now, on one more step, now the moles of AlCl3, they can cross from way here to here, and then I'm going to say 1 mole of AgCl is equal to so many grams of AgCl. Now this number comes from the periodic table, so let's go our trusty dusty calculator, and I can say a silver, as I happen to know, weighs 107. Turn it on, I guess, right? 107 plus 35.5 gives me 142.5. So this is 142 and a half. And by the way, the moles cancel here. So I'm going to be left with grams of AgCl. Now, big stoichiometry thing, I'm going to take 0.25 times 0.05 times 3 times 142.5, and that gives me 5.34 grams of silver chloride. That's the answer. Notice it's just adding a sort of a big stoichiometric m times v. I started with m times v. Oh, by the way, another way you could have done this, you could say mv equals moles, and I could have said m is 0.25 times 0.05. That's my moles, and then I could have started here with that number and moved on. Now let me say just one more thing. I'm not going to do another example, but I'll talk it through. Let's say I didn't just say you had 50 milliliters of 0.25 molar, but you also had, let's say, 50 milliliters of 0.10 molar silver nitrate. Now, I don't know if you realize this, but now we've just introduced a limiting reactant. So one of these two is the limiting reactant. And so what I would do is I would do the exact same type of math. I would convert this to grams of this using the exact same process. So I'd have a second stoichiometric line, and the lowest answer would win, right? The lowest answer would be the one that gave you the limiting reactants. An alternate method that I've seen, that I actually usually use with my AP students, is we convert both of these to moles, and then we can kind of just do some mental math and say, oh, well, I need 3 times more of this. So let's say I came up with a number. Let's pick whole numbers for the sake of argument. I came up with 3 moles here and 3 moles here. Just an even number, just for the sake of argument. But in this case, I need 3 times more, right? If I have 3 of these, I actually need 9 of these, if you think about it, right? And so this would be my limiting reactant, and I could sort of skip a step, and I could convert from here to here. So you're going to do a lot of problems in class where you're going to be doing solution stoichiometric problems. Key thing is MV equals moles. If you get there, you can do solution stoichiometry problems. It's not that hard. Now we're done with our unit on solutions. Congratulations, you made it to the end.